So we will try to do as more dynamic possible so you don't get asleep. Okay, my name is Eduardo Silva, and one of the creators of my internet this project called FluentBet. I was involved in the FluentD team for many years at a previous company, and actually I'm a CEO and co-founder of this company called Calyptia, and a CNCF folk from many, many years ago, since the beginnings of Kubernetes. And everybody talks about observability in general, and I think that the term is very crowded, right? But actually, the only thing that matters in this space is that the ability that you have to analyze data, right? Observability is like the big category, right? Because at the business or in your companies, you just want to analyze data, extract value. Otherwise, the data is just garbage, right? But when we talk about observability, we have to understand also what are the complexity of getting this telemetry data, or what it involves in general. And as I said, the goals of telemetry is just data analysis, take business decisions, and this also touches many areas like security, performance, or cost associated to infrastructure in general. And the challenges that we have today, well, actually everybody says today, but this comes from many, many years ago. We have multiple sources of data. We have data that comes in different formats. And if you want to perform data analysis, you understand that you have a complexity. We are not like 10 years ago where you just have a few dozen of servers. Now we have hundreds, if no more. We work with corporation which has 100,000 servers, right? So doing data analytics at that scale is really complex. And we're going to focus just on 3 types of telemetry data. I know that there is a 4th, there's a 5th around, but we just purely focus on logs, metrics, and traces. And logs, I would say that is, well, everybody get it, right? The logs is a more old system for an application to say, hey, what's wrong, or what I'm doing, right? Everything logging is about what's the application doing, right? It's like a journey, right? And we have different actors that generate this type of data. One of them are the user-level applications. You can use your web app or your program that you wrote. And most of the time, this data come in a very raw text format or unstructured. And the biggest problem is like you have one developer today that they say, oh, this is a way to do login. And you get 10 developers, 20 developers, and all of them will write a different structure that they think that is right? And actually, this is not a problem for developers. This is an industry problem that we have. And I had serious doubts that this will get solved. But at least we cannot change people's mind on structure around how to compose data. But at least we can have the right tools to deal with that problem. Because our final goal is not structured data. Our final goal is data analysis, right? And structured data is just one way to simplify the process. And from the operating system application, yeah, we have syslog or services running through systemd that just connect all the stuff and generate useful information for us. And from the operating system level, yeah, the kernel, which runs in kernel space, also it's exposed its own login APIs or facilities. So this is just what could happen in one box, right? If you multiply this for 100, it gets really complex. In the other side, metrics, right? It's aimed to be a more specific information, a number information about the behavior of an application. We understand metrics like how much CPU my application is consuming, but also that application can expose metrics. For example, if you think about a web server like Nginx or Apache, they're always shipping metrics, right? Or they're saying, yeah, I got X number of requests with this status code. And why do I care about metrics? Because I want to improve performance, or also if I'm finding that the metrics generated by the application are saying, hey, I'm getting many errors, and nobody's noticing that, you should be able to create an alert, a pattern, and say, hey, if I'm finding this type of pattern in the metrics, there's something wrong, I need to page somebody, right? Application crashes the whole day. There's no stable application, right? And in metrics, different than logs. For example, in logs, you have raw text, or you can say, oh, JSON is a structure. Yeah, but JSON is a structure that is understood by the human, unless you apply a parser and you create, a binary representation for it for the computer. And in metrics, from the data type perspective, we have counters, right? Counters always goes up, right? It's like when you are, your birthday, you never go down. You always go up until, you reach end of life. Gauges goes up, goes down. Temperature, histograms, and summaries is a way also to take the data and not analyze all the samples individually, but put it into buckets and say, hey, let's try to get not an average, but in buckets that could say percentiles or where this data is going to, where it's going from, right? So metrics are quite interesting and mostly usable around everywhere. And traces got very, very popular. And why they got popular? Because if you think years ago, most of the applications were monolithic. Right? You have the application, you have the database. Application issue a request, get a response, and that's it. But with all this movement of distributed systems, right, where people say, oh, let's distribute the application in multiple components, and now that's going through containers, right? So every time that you get a request, this application A talks to B, which talks to C, which C return back to B, and B return back to, to A or to the client. And if you think that you want to do logging at that level, if something goes wrong, you don't know where it got wrong, right? Unless you implement some logging that you can trace together, right? So if I issue a request to an application, and this application depends on 2-3 components, tracing allows me to have a global view of this data, right? And we have a specific concept around spans and attributes. And one of the downsides of this, and this is one of the challenges, is that in order to get tracing, you have to instrument the application. For example, in logging, the application just prints some data. You just take this data and you just process it. But in tracing, you have to instrument the application. And if you have 5 applications in different languages, you need to have a unified way to instrument those applications. Now, there's an interesting concept also that is called black tracing, or there's kind of new names, where you can say, hey, maybe I know that this application is creating a TCP connection to a second service. That's kind of a system. Okay, the application asks the operating system through a system call, please connect to this place. And the other will do the same. And both will do network connection, or they will do a connect, they will do a socket creation, a connect, a write, a read, all these kind of operations. And eBPF comes in as a solution to say, hey, what about if we instrument all these system calls? So without instrumenting, the application, I just take a look inside the application to what resources this application is using at the operating system level. So I can trace the connection anyways. Yeah, it's another type of monitoring, right? Which one is ideal is case by case. In this world of observability and tracing, there's no single solution for everything. Be clear about that. Yeah, you will be pitched about many projects, even for logging metrics and traces, but when you go to production, you will find that sometimes you have to implement different tools to solve the problem in different ways. Okay? And now we start talking about telemetry, but the industry standards, right? When I say industry standards, I'm referring to what companies are really using in production. For logs, even if you deploy like a Linux box, right, you will get our syslog by default. It's there right away. And our syslog, yeah, it's like a syslog server that allows you to store syslog messages from the application, but also forward these messages to other our syslog servers. But also our syslog quite powerful because support other type of backend that are not just a syslog. Years ago, we started creating FluentD, more than 10 years ago, which was a solution to unify logging in a way that do not depend on a specific standard. Because what we started noticing is like people were using syslog, but others were using routex, but others were implementing JSON. So syslog is not the answer for everything, but you needed something that was able to deal with all this format and came from different sources. And yeah, when you get a problem in production, hey, where are the logs? What are the logs saying? And if you don't have the logs in one place to analyze, yeah, you're blind. Or you had to get into each specific machine and try to see where the problem is. FluentD was created, FluentD is written in a Ruby language, and you wouldn't be surprised, yeah, scripting language for service level applications. But it solves the problem. That's a good thing, right? And nowadays, FluentD has more than 1,000 plugins contributed by the community to deal with different sources, different formats. But 6, 7 years ago, we started saying that, hey, FluentD, cool, it works, but we're getting into this containerized world. We're getting into this new world of container distributed systems, and FluentD is Ruby, it's quite heavy, right? And you have more data to process, and Ruby is not multi-thread. It doesn't, to be very honest. So I started FluentBit, part of the same team, but FluentBit took the best experience of FluentD as an architecture from a pluggable architecture dealing with different sources and formats, but we wrote the agent in C language, optimized it for performance, right? And this is one thing. Everybody talk about performance, number of requests per second or number of events per second. But nobody asked themselves how many resources you need to handle that. So what is important in performance in general is, yeah, you are able to handle the load, but that has a cost. And from a project perspective, we just make sure that FluentBit is the cheapest solution that achieves higher performance, right? Maybe if you have a couple of boxes for log management, yeah, you might not, it won't be a problem. But when you're running at scale, it matters. If you're running a cloud on AWS or other places, yeah, that really matters. So the industry runs on this right now. There are others like syslog, NG, and other commercial offerings. I'm just referring to a few ones. Now, in the industry standard for metrics, and this is kind of a debate with people, right? But if you go and talk to companies, today, everybody uses Prometheus. They standardize metrics collection, they standardize metrics processing through Prometheus. Yeah, there are many other solutions for metrics right now, but this is what the industry is running today. And we found that on these kind of applications, it happened to us on FluentD and FluentBit, to get adoption on a new tool or get a wide adoption on a new format, it takes 3 to 4 years, right? And usually the pattern is what cloud providers are using, smaller companies follows. If AWS says, I'm using this tool, we're going to use it because AWS is using it. You trust that they are making sure that that tool is reliable and works fine. Previously, everybody was handling monitoring with Nagios, and Open Metrics is kind of the standard that Prometheus used to handle the metrics types, counters, gauges, format, how to transfer this information from one place to the other. And in the tracing world, in the past, we had Open Tracing. Open Tracing was the fact project that was incubated and graduated at the CNCF that managed all of these. But then Open Tracing started to evolve and merge with another project which gives life to Open Telemetry. And Open Telemetry is a project that aims to unify how logs, metrics, and traces are handled from a protocol perspective. Open Telemetry born as a specification, but also they provide tools to instrument applications, right? But also they provide tools for aggregate, like the collector, to aggregate data and process the data. Now, in the industry pieces, OpenTelemetry today is widely used for tracing. If you go to cloud providers now, for example, I can mention two, Amazon or Google, metrics, purely Prometheus. Traces, purely OpenMetrics. Logs, purely FluentBit. So it's interesting to see how companies start working with different projects to solve the problem. Actually, yeah, so what I'm trying to say is like OpenTelemetry is a new project. For traces, it's really, really stable. But for metrics, I think that this is still in an early adoption phase. Same as log. I think logs are still behind metrics in the OpenTelemetry. The specification is there, but it's taking time to get the wide adoption. And what are the challenges with telemetry in general? As I said at the beginning, multiple sources, multiple formats. And guess what? In your company, you know that. Who of you deploy applications? Are you a DevOps sysadmin? Okay. You might understand that you're deploying more applications every year. And actually, you are having 20 to 30% more data every year, right? So if today, the implementation that you put today to handle the load of this telemetry data, maybe will work for the next year, maybe not. Because nowadays, the environments are quite dynamic, right? In the past, you used to have you just bare metal servers or maybe a couple of VMs, so it took some time to scale up the infrastructure. But now you just click one button and you can, I don't know, spawn a couple of VMs or spawn a couple of containers, right? And now you have more data to handle, and that is the biggest problem. Are you familiar with back pressure? It happens to you at your home when you're washing your hands and sometimes you put more water than the capacity of the pipe. What happens? What happens with the water? It flows, goes out, back pressure. So back pressure in this term is about how much resistance you have in the pipe, but in technical terms is my water is my data. I'm getting the data into the pipe, but what about if the pipe doesn't have the capacity to handle that amount of data? Or maybe it has the capacity. It flows through it, but when you're going to send the data to your database or destination, the database says, hey, stop, I can't, wait, retry. You saturate the pipe. And who sends the data to? And that is back pressure. And that is a really, really common problem that you will face. Now, how do you prepare for that? First of all, the solution that you have in place needs to be able to detect back pressure. And how do I detect back pressure? It's easily. If I'm trying to send the data twice to a database and I'm failing, hey, maybe I need to pause and retry later. Or I need to slow down. But if I don't want to lose data, I need to buffer that data. There's always pros and cons and downsides on how do I move data from one place to the other. And in general, yeah, it's performance. For some people, it's speed. For others, resource usage. And I think that is always try to find this middle point. And this is also how FluentBit was born, right? I was saying that FluentD was quite heavy, and I'm going to tell you the truth. FluentBit was created for embedded Linux 7 years ago. Because 7 years ago, everybody was talking about IoT, connected devices, billion connected devices, right? And now, yeah, that stuff is not working at home, right? We have a few cameras and they are struggling. Right? So, but we knew that if we have a bunch of remote devices connected, those devices generate data. You need to collect the data because you want to analyze the data. And FluentD was not a suitable solution for that because it needs like 50 or 60 megabytes to run. So FluentBit was created where it was using less than 1 megabyte, right? Reading and C, pretty optimized, and it has all the connectors inside for HTTP, TCP, systemd, you can name it. And at that time, part of the story, FluentD was bigger than us, FluentBit got bigger than us, and we just donated the projects at the CNCF. So FluentBit is like a sub-project of FluentD, and both are in a graduation state with the CNCF. And FluentBit nowadays, well, first of all, it's a full telemetry agent. FluentBit, it supports, can handle logs, can handle metrics, can handle traces. Now you're asking yourself, oh, should I use FluentBit for everything? I said that you should use something that solves the problem for you, but also you might connect with other solutions, and FluentBit is not the single thing for everything. Okay? I just want to be very, very clear about that. And who use FluentBit at a very, very high scale? Amazon, every infrastructure server of Amazon, not the customer ones, but the infrastructure runs FluentBit, same as Microsoft, same as Google Cloud. Actually, all of these companies, the top 3, are contributing back to the project, either through commercial relationship with Calypso, the company behind FluentBit now, or putting engineering resources. AWS has an engineering team working on FluentBit too. And it is important to mention because when you implement a strategy for infrastructure, you want to make sure that the project that you are deploying right? Infrastructure, is not something you want to change every day, right? Change agents, change the software takes time. So when you're deploying something, you want to make sure that the software that you're deploying will be running and will be supported with bug fixes and security fixes for a couple of years. And being fluentd and fluentbit with the CNCF, same as Prometheus, same as OpenTelemetry, gives you that warranty because it's not a solo developer in the project. There are many companies contributing to it. So you can rely on that. It's not like a bank, right? If you know what I mean. And fluentbit as a telemetry agent is not just do everything with fluentbit. It's also, does not give you a position, just go and be a drop-in replacement. Actually, just use it, but integrate it with what you have in your environment. And I'm talking with Prometheus, OpenMetrics, with fluentd, with OpenTelemetry, right? So you will find many cases in observability that you want to handle logs, you want to handle metrics, and somebody from the, is saying, oh, let's do everything OpenTelemetry. But maybe the collector is a bit heavy for the environments, and you have 100 machines, and you cannot have an agent in general that saturates your machine because you have more applications running on it. So you have to be very cautious what you deploy and what. And that's one of the value of fluentbit. And a fluentbit as an agent, as a program, the concept is pretty simple. You have sources and you have destinations. Sources is data how it can receive data, where it can receive it. For example, it can receive for multiple protocols, syslog, firewalls, TCP, file system, systemd, kernel log messages. We have internal plugins for almost everything. We don't have 1,000 plugins like fluentd, but we have I think there was 110, which is a lot. And in the output side, yeah, we support most of the vendors and backends that you might be using in production: Splunk, OpenSearch, Elastic, Amazon S3, CloudWatch, Google Stackdriver. And the good thing is that all of these features are built inside the binary. That means that you don't need to go and deploy. We have got the problem with fluentd, since it's based on Ruby, so we had to create different container images for different users. Oh, this image is for AWS, this image is for Splunk, right? And from a maintenance perspective, it was really hard. And at some point, if you said, oh, I'm using Splunk plus S3, oh, that image doesn't exist, so you have to build it your own and maintain it your own. That was a complexity. So in fluentbit, we just make sure to ship everything inside the same binary. So the same container today, it has support for everything. Or the RPM packages or Debian packages. Okay, I would like to make a pause and check if you have some questions as of now. We're going to do some quick demos on how it works, but I would like to know if you have any questions around. I know there are many around OpenTelemetry, Metrics, Prometheus. I got many questions this week around that. I always want to make sure give you some space for questions now. Otherwise, we can do the questions at the end. No? Continue? Okay, okay. You're not sleeping, that's good. Okay, so fluentbit is an agent, it's a software, it's a binary that runs behind the scenes, right? It's a type of software that you want to deploy and just forget about it. But the first time you had to configure it. So it's like a Unix file, so you will be familiar with it. Oops, let me check here. It's too small or? There? Better? Little bigger? Cool? Oh, the guys in the bottom. There? This? Okay. Let me check if I have fluentbit run. Oh, it's not here. This is a development version. Yeah, okay. So we go with the demo 1. And as you know, demo 1, what it's doing is we're going to show very, very basic configurations to accomplish different things. The first one is that we're going to parse a common web server log and do something with it. Okay? And I want that you get familiar with the configuration of Fluentbit. Oh, this is a classic mode configuration. Okay, and this classic mode, oh, you have a question? Yeah, sure. Yeah, we support many protocols, okay? But for firewalls specifically, yeah, just configure your firewall to ship syslog, and that's it. We support syslog through TCP, UDP, Unix socket. That works for everybody. Yeah, don't talk to me about the formats because syslog formats is another mess. Yeah. Yeah, I don't have a firewall here, but we can talk about it. Yeah, sure. That's fine. Okay, so first we define a service section. This configuration mode is called classic, right? But now we support YAML too. But I wanted to use classic because, yeah, it's more familiar to our users. It gets easier. The important thing is that you have sections. One that you define the service, and the other one you can define inputs and outputs. You can have multiple inputs, multiple outputs. And also you can route the data between them. It's not just one input, one output. Okay? So the first exercise, we're going to take the tail. I don't know if you can see it. Is it split or can you see the whole screen? Oh, okay. Bigger? Better. Okay, thank you. So tail, what it does is like the tail command allows you to follow files. Okay? It's not doing a exec or forking a process behind the scene. No, it's just pure implementation in C. What it's going to do is just to read this file. I just put the name of the file, but you can use wildcard, you can use a subdirectory and say, hey, process everything that matches log. And I'm going to read the file from the beginning. Actually, I'm going to do an exercise and remove this configuration. I'm not going to apply a parser. So I just want to make sure that I'm going to read the file as a raw data, just lines. Okay? And what I'm going to do is to send this data to the standard output to the terminal, because this is just an exercise, and then send it over HTTP, right, to a new open source project that I found that's called Parsable. It looks pretty cool. Well, you can visualize logs, basically. You have a question? No. Yeah, the concept. Yeah, so yeah, the tail plugin, what it does is like scan the directory using the C API. It uses iNotify system call to monitor file to check when the file has been changed. So it remembers the position of the file and read new chunks every time that there's more data in a new file. Here we can go very technical, so if you want to take a look at the source code, all of it. We have 1 hour, so that's really good. We're not in a rush with the common 30 minutes conference. Okay. Yeah.
Does Fluentbit inject the timestamp when it retails a new line from the log?
Yeah, that's a good question. The question is, does Fluentbit ingest a timestamp when you read the log? When you read a line, that line, if you don't apply a parser, Fluentbit will apply its own timestamp. This is when I read it. But if you apply a parser, and the parser knows how to read the timestamp from the content, it will use that timestamp. Yeah. Okay. Let me check something here. Oh. Okay. What I'm gonna do is to work in two tabs because I think that. Oops. Close. You might notice I'm new in Mac. Why can I exit? That's fun. Okay. What I'm going to do here is run, I can show you the script. I'm just running this project, Parsable. It looks pretty cool, you give it a try. It's really simple to visualize logs. That's what I'm using it. I'm not saying using it for production. I don't know more about it, right? Disclaimer. So I'm going to use it like a local server to receive the data. And okay, this is a parsable UI, but I'm not running FluentBit yet. So what I'm going to run is FluentBit -c. Of course, when you're running this in automation, use systemd or the unit files. It runs naturally, right? So the first thing that I did, this gets a little bit complex, which is I took the data from the file that I'm monitoring. It's an nginx log file. My mistake, I didn't show you the content. I will show you right now. And I just print it to the standard output, but also I send it to this backend service, which is parsable. And if I go here, you will find the records. Okay, this is actually my backend for logs. Now, you will see that you're reading, oh, I understand, because there's a timestamp, there's a content for the file. But the question is, does it have a structure? Oh, you guess that it has it, but actually it doesn't, because everything is under a key that is called log. Now, the important piece here, for example, if we show you the access log file, yeah, this is log file, nginx log file, example. Now what I'm going to do is open the configuration file for FluentBit and now do some parsing. I'm going to apply the parser called nginx. And to answer your question, I'm going to show you how parsers works. Parsers are just definitions on how to analyze data, and could be by using JSON or by using regular expressions or LTSV or CSV. So this is an nginx parser. So you just register your parsers in a configuration, but of course we try to ship all these parsers ready to go, right? So you don't need to write them. Nobody likes to play with regular expressions. Well, not me at least. And here's how you can discover the timestamp. So you tell it what is the key that contains the timestamp, and you tell it later what is the expected format, so it can use it. Yeah, if it cannot discover, do the lookup, it will fail. It will fail to apply that timestamp. Okay, so, and if we run it again, I'm going to refresh here. You will see now a new columns here. Timestamp, agent, code. This is the new data that was ingested. The previous one was just raw data. Now we have a structure. And why a structure is important? Because you can filter the data and you can say, for example, the code that contains 200, add filter, and fails. Oops, how this works? Let's learn together. Code contains 200. Oops, it's not working the parsable filter. But you get it. You will want to query by the, by the status code or by other columns that you have. So what is good to you to do a parsing is because you want to structure the data. Because at some point you want to do queries by using the IP address from this data or from the path that somebody tried to access it. But if you go to parse this raw data, yeah, it becomes more expensive. Traditional systems like SIM system tell you, send me all the raw data, I will do this for you. But don't get into that trap because they're telling you that, so you send all your data, you pay more money, right? So always structure your data first and send the data that you want to your backend. There's a couple of companies that has that business model. One starts with S and ends with Splunk. So you're facing that, right? Okay. So as you can see, parse data, you have parsers, you can do files, and send this over HTTP or to any other endpoint. The second demo is about scripting, right? Oh, I didn't modify that. Why? I didn't save it. Scripting. Why you will need scripting in an agent? Have you used Nginx web server? Did you try Lua at some point? Okay, one of the problems when moving data from one place to the other is that you always has a huge business logic. And sometimes you want that your agent or your pipeline do something based on my own personal decisions. For example, if the data contains this value, modify the content before send the data, right? That's called enrichment, to filter out data because maybe you want to reduce your cost, and your smartest developer deploy in production and enable debug messages. And now you're shipping thousands of messages per second to your backend that you're paying for it, right? You might want to detect that. So with scripting, you can create a rule that says, hey, if you find something that is called debug, just drop it. Or maybe some common use case that I'm going to show you right now is like, imagine that you have this message. This is an example. Oh, where is that? Not here. Oh, it's here. I got confused. Sorry about that. For example, I have an input plugin that is called dummy. Dummy just generates a dummy message. That's for testing purposes. And the message that is going to generate is an event. So it's an event that has a key called event with a value and with a year. And it's going to send it to the standard output. It takes like a second because that's buffering, not because it's slow, right? And it just ships the same message over and over. At some point, somebody tells you, oh, you know what? Before receiving this data on my database, I need that this data contains certain keys with certain parameters. Host name, security, environment, whatever. So we support Lua scripting, and Lua scripting allows you to program in a configuration a way to modify the data. So, and the way that it works is you're going to Flow Embed. Same as we have inputs, we have the concept of filters. Filters allows you to enrich or discard data based on some pattern. We have a couple of filters. I'm going to load the Lua filter. Lua is a scripting language. It's used by Roblox, Nginx, everywhere. And I'm going to load this file, which is called scale.lua, and invoke this function, scale test. And this function, what it does, is pretty simple. Every record that gets into the function comes with a tag. It's used for routing, the timestamp, and the record itself. Basically, what we're going to do is take the record, and we can say here, we're going to add a new key, environment, because all data coming from here maybe is just, I don't know, production. And I return 1 because I'm modifying the data, the timestamp, and the record. When I save this and I run this again, you will see now that the data comes with a new key. Pretty simple concept, but you can bring your business logic into the pipeline. You can modify or just discard the data, right? Lua is a very flexible and powerful language. That's, yeah. You can add many filters if you want. Yeah. That's a good thing because you know how this Lua, as part of the story, how the Lua scripting language was born? I don't know if you remember that GDPR was implemented a couple of years ago in Europe, like 5, 6 years. We got a couple of companies that after one presentation, they said, hey, we need to modify the data before sending it to destination. I told them, yeah, write a plugin in C. Oh, we can't. And I asked, okay, what is the use case? You know, GDPR is coming, and what we are flowing through Flow Embed at that time was transaction information. So in the logs generated by the application, the credit card number was included. And they said, if this credit card number is coming, I know how to detect if an Amex is a Visa or any other type. But how I can put my logic to say, okay, if it's from Visa, do XYZ. If it's Amex, do something different. And in a conversation after one coffee, okay, let's do something with the scripting because Nginx was doing that already. So we implemented the Lua filter. And now everybody is using the Lua filter to do, even for security reasons. For example, when we have a filter, we don't have, one company has a filter, that when you get the data, the Lua filter goes to an API endpoint, validates certain criteria from that data, and checks if it's an anomaly or not. It does anomaly detection with Lua. So it can be very powerful or simple, from adding a key to do something more fancy. Yeah, and Lua is pretty easy. It's even simpler than JavaScript. Stay away from it, from JavaScript. If you can, right? I try, but okay. So that was a kind of data modification, scripting. That was the right slide. It was duplicated. Sorry about that. Let's fix it. Okay, the next demo. This gets a bit more complex about, not complex, but how to move data. It's kind of demo. The problem is now is like application ships logs, application ships metrics and traces. And I said, okay, what kind of tool should I use, right? My first answer is use something that is from the CNCF, from the Cloud Native Computing Foundation, because you're going to make sure that these projects are fully backed by the foundation and hundreds of companies behind them. So it's something that works in production. Now, as other demo, it's like we have a JavaScript application as a demo that ships OpenTelemetry metrics by using the instrumentation from OpenTelemetry. It does OpenTelemetry traces, but those are not sent to the OpenTelemetry collector, are sent to FluEmbed. And what FluEmbed does, it sends the traces to Jagger, right? Where Jagger is a visualization for tracing. It doesn't send the metrics, but it does something really cool, which is a metrics exporter. Are you familiar with metrics exporter? Yeah? Or some of you? Okay. Maybe I can dig into that. When doing metrics in Prometheus world, it's pretty much based on a pull mechanism. The application doesn't push the metrics. The applications open an HTTP endpoint, and you let Prometheus scrape those metrics for you. That's the way it was designed at SoundCloud when Prometheus was created. And that's what everybody's running right now. So if you don't need to send the metrics, you just wait for somebody to pull the metrics. It's good, it's bad, it depends on the case, right? We're not going to get into that dispute or between languages, which is better, right? And so what we're doing for the metrics that we receive in FluEmbed, we are exposing them in an HTTP endpoint inside FluEmbed and let Prometheus scrape those. But FluEmbed also can ship metrics if you want. You can relay forward all of them. And then we're going to visualize those metrics with Grafana, and also FluEmbed is going to send the data to an OpenTelemetry collector, right? This is just to show, this is not something you're going to deploy in production like that, right? This is just to show how versatile it is, and you can translate data from different protocols and connect with different worlds, specifically around Prometheus and OpenTelemetry. Since this example gets more complex, we have one project which is open source in our Fluent repository on GitHub called FluEmbed Observability Demo, which this is an old version. A new ones we're going to be shipping in a few weeks, that trying to show all the use cases for this type of technology. So we just need to do a Docker Compose app. I hope that the Wi-Fi is with me today. Ooh, Grafana is already in use by a container. Oh, let's kill it. And this one. Should be that one. There we go. So we're starting all the applications, the JavaScript application, Grafana, Jagger, and all of that. Okay, and I'm going to my cheat sheet here to so here's Jagger, basic service. So I'm starting seeing the traces that are arriving here from FluEmbed. This is a very dummy application. We don't have a huge application with 3 services connecting to each other. This is the most basic version of this demo. So Jagger is receiving the data, which is good. So you remember that this application is sending data to FluentBed and send it here to Jagger. Now we are going to, with Grafana, I think this is a new setup, so we need to do everything again. Oh, here's the data is coming in. These are the metrics that are being shipped by the initial application here. So what we did was, remember, the JavaScript application sent the OpenTelemetry metrics to FluentBed. FluentBed opens an HTTP endpoint, which Prometheus is scraping those metrics, and then Grafana is stealing those metrics from Prometheus and building a cool dashboard like this. Okay, so you can see that all the stuff is connected together. Now, we have some minutes for questions. If you want, I can go deep into FluentBit internals, data serialization patterns, routing, and how the engine works if you want. But before that, I wanted to let you know that FluentBit 2.1 is coming in a few weeks. And as you know, I have a FluentBit. This is a 2.1 t-shirt, but just say 2 for simplicity. And if you want to grab one, you just, before leaving the room, just ask our team that is in there, and we'll hand you over one t-shirt for you. But you have to wear it. So what's coming on 2.1? Log metadata support. This was one of the complexities. We didn't support metadata for logs. Actually, everything was inside the same log. The other question, feature that is coming is hot reload, because this is the major requirements, how I can modify the configuration of the agent and making sure that it hot restart and it continue processing data. That's one, and the other performance improvements. So I think we're going to give some minutes for Q&A, and if you want, we can jump into internals.
I have one question. You have FluentBit collecting stuff, and you have to send it to Prometheus and then to Grafana to get these nice reports, or is there another alternative for generating the reports?
Yeah, actually, you know, Prometheus has a protocol that is called remote write. I don't know if you heard about it. Yeah, it's a protocol implemented in Prometheus to talk to Prometheus instances, but not with applications. FluentBit supports remote write. So, for example, if you're going to send metrics, for example, to New Relic, I'm talking about vendors, New Relic or Google Login, or AWS, all of them support remote write as an endpoint. So in FluentBit, you just configure remote write as the output, and you can ship the metrics in a very smooth way. Right? It's a very common pattern if you're relying on external services. Oh yeah, I think that works, or you can use OpenTelemetry endpoints. So you do FluentBit metrics to an OpenTelemetry receiver. Yeah.
Hi.
Yeah. Hi.
So you show FluentBit to serve for traces and for metrics, but then you said don't do this in production. Why is that? I mean, why FluentBit would be able to do all, to cover all these fields, and why wouldn't you use it in production?
Why would you use it in production? If you're doing, I'm going to be very honest, if you're going to just use tracing, you might use the OpenTelemetry collector, because if you're doing tracing, you want to do sampling. There's head sampling when in application and tail sampling. Tail sampling, we don't support that in FluentBit. So if you're doing tracing, yeah, use the OpenTelemetry collector for that. If you want, the thing is that using OpenTelemetry, maybe you want to extend the use of the protocol, the OTLP, in your environment. But now you say, oh, I'm going to instrument my applications. But I'm already using FluentBit. I'm going to increase OpenTelemetry collector instances, or I can use the same FluentBit. So if you want to connect your applications, you can use the same FluentBit agent that you have. That's another option. Yeah.
So I'm familiar with FluentD from using OpenShift. it's a set it and forget it thing for us. It just came with the product. So it's good to kind of see the true power of it. But one thing we've noticed, when the cluster starts to have issues, we notice that, CPU spikes from Fluent D specifically as well. So do you know if Fluent Bit will address that issue and if they'll adopt Fluent Bit?
Yep. You can do 10x more with 80% less than Fluent D. Yeah, that's why most people are migrating to Fluent Bit. Well, cloud providers did it already. Yeah. I think that Red Hat is investing in another agent right now. No, log is just to store logs. Yeah. I think that Red Hat always tried to be very agnostic on how you ship the data. It gives you one default if you want to use it, but it tries to not get married with the, same as Kubernetes, right? You don't have a real default. Yeah. Oh, I have a question. The gentleman.
Actually, I want you to have the mic because we're recording this.
Oh, I see, sorry. So you identified the expansion at the beginning of your talk. Is your product that's the design of the product, is to understand the growth of that product itself, besides what other logging you expect, but that's one of your focuses with this platform?
Yeah, when I mentioned the 30%, I was talking about information from for Calyptia customers that they are budgeting, the storage for the next year, and they are seeing a pattern of 20 to 30% growth in data every year. So the biggest pain for them is cost, 20 to 30%, and then it's like, okay, are my tools able to handle the next 20 to 30%? And they choose Fluent Bit, and we work together every year to push boundaries, optimize it even more. We started processing, 10,000 messages per second for a very intensive workload with parsing, and now we are around 60,000, 70,000, I don't know. So there's always more ways to improve performance. We implemented threading, we implemented a lot of optimization of how do we serialize the data internally. So the problem is there's more data, and people need a way to process this data before hitting the endpoints. But yeah, so data is growing every year. It's insane.
More questions? Okay, we have 10 minutes if you want to show some internals.
Awesome, cool. Thanks for coming, and enjoy your rest of the day. If you have more questions, I will be here, and please grab your T-shirt.
We have 10 minutes left if you wanted to actually do the internals. Yes, no?
Do you want internals? Yes. Okay. Bring the beers. Yeah. Okay, so FluentBit was designed with performance in mind, right? And when you think about performance, it's about how I can run faster by eating less or consuming less energy, right? If you buy a car, right, and your car was really, really, really fast, but you had to put a lot of gas on it, it's not the same that a car that achieves the same performance or more with less energy. That is performance, right? And in software, it's the same. So we started analyzing how we can process data in a way that is the cheapest way possible with less CPU, less memory, but also that I can achieve really high rates of data transfer and movement. The data internally in FluentBit, we can receive JSON, we can receive a protobuf, but internally we serialize the data in something that is called message pack. Have you heard about it? No, okay, message pack is like a binary JSON. And why binary JSON is important, or a binary kind of JSON? Because you don't need to analyze the whole data to extract some content. You know that you have a key on this position, you have a value, and then follow the others and the others. So if you want to jump into, you have this record, you can jump just into the middle, and get the right key that you want. It's not indexing, it's how the data is serialized, right? But also the data, when you are processing data, You might think, oh, where is this data in, right? It needs to be in memory. But what about if FluentBit crashes? What about if the output destination where you're sending the data is down, right? How do you handle performance plus reliability? And that's one of the complex concepts. For example, as a workflow, an application sends a message. I'm going to go through the workflow. The message gets into the file system. This is like a web server example. And then you get many of them. Following, you have many files with many records that need to go through an engine and need to be delivered to your final destination. And the work of the engine is collect the data from different sources, allow transformation or understand structures for the data, but also do metadata enrichment. We didn't talk about metadata enrichment, but for example, if you deploy FluentBit in Kubernetes, you want to make sure that the logs that you're collecting for some 10 applications contains the labels, contains the annotations. Because when you're doing data analysis, you're not going to query by the application name. You're going to query by using certain labels that you defined beforehand. It needs to do buffering because you need to have the data somewhere when you're processing the data and then be able to send it out. And also, well, it needs to support how to connect to destinations. Imagine the world before FluentD and FluentBit, it was a mess because you used to have many scripts for different type of data and different destinations. So we have this concept of input and output. And basically, this is A to B, plus processing in the middle. And in the input side, we had to deal with many things: I/O, disk, networks, and metrics. Because I'm not just reading a file, I'm reading data from UDP, from a TCP, or maybe an opening the kernel log messages device, the dev KMSG, right? The engine, from an architectural perspective, takes care about parsing, filtering, serialize the data, buffer the data somewhere, and route the data to a destination, and schedule how the data will be, when will be delivered, and if it fails, how many times it's going to retry and when. Imagine this scenario. Your backend is down. You are sending all the data. Are you going to retry all the data at once? You might saturate the service, or you might saturate your network, or your own service. What you do, if all my data is failing to be delivered, and I had all these chunks are a way that we group data. You can say, okay, I'm going to try this chunk at second number 10, the other second number 12, with a back of an exponential calculation, so you don't try all the data. But all of this needs to be scheduled and is handled by the engine. And in the other side, the output plugins, the output just does, hey, I need to how to connect to this place because you're going to send the data. It's a network setup. I need to format the data. Remember that I mentioned that when we do serialization in the middle, it's purely message pack. But I cannot send message pack to Elasticsearch or to Splunk, right? They have their own format in JSON. So every output plugin needs to get the data and format the data for the expected payload by the receiver of that data. Deliver the content, well, try to deliver, making sure that the data was received. And there are 3 status when I try to send the data. It was okay, there was an error, or I need to retry. An error is something that you cannot recover, meaning like maybe the format of my data, there's no way I can change it, that it can be ingested. So there's no sense on retrying the data. It will fail. And retries. So collecting logs is, well, this was pretty much initially designed for logs FluentBit, then we extended the scope to metrics and traces. It gets really complex. And from a data serialization standpoint, this is a comparison of sizes that you use in JSON versus a message pack. There's quite of optimization in space in there, plus you don't need to process the data byte per byte. You just can jump between positions of keys. But also it supports different data types like null, integers, arrays, maps, strings. The good thing about message pack, it doesn't care about encoding. It's not like JSON, right? If you put some weird character, you have to escape it, or if you have an UTF-8 character, you have to encode it, right? Here, message pack is fully binary, so it doesn't care. The data starts here, ends there, and has a type. and that's it. And in the way internally, I mentioned a concept a couple of times that is called chunk. So a chunk are a couple of records or events that belongs to the same context. For example, if I'm reading a file, right, that file will become a chunk, and that chunk will contain all the data, and also has the concept of a tag. A tag is usually used for routing. A tag is like a label that says, oh, this is a file name, or I can apply a tag manually. And when a chunk is created, we start talking about buffering. Hey, where this chunk is going to live? Of course, it will be in memory. So what it does, the engine does is start creating chunks in memory for different files or for different groups of data. But you might guess that at some point, it's really fast. The thing is that it's not persistent. So if you restart the agent while you have data just in memory, yeah, you're going to lose that data because the memory is volatile, right? Also, the other problem is that you're ingesting so much data and you consume so much memory, the kernel will tap your shoulder and say, hey, man, it's time to go. Or OM killer. You're going to be killed because you're consuming so much memory that we need a space for the other processes. So this model cannot work in production, right? Actually, the first version was just memory, and it was a mess because it was crashing, right? People ingested more data, and it generated a lot of back pressure because it was so fast to collect data that put data so fast in memory, but the backend was not fast enough to receive that data. So it generated back pressure, it accumulated data in memory, and the kernel killed it. Okay, but there's always a solution for everything. So we created this hybrid buffering mechanism, where now we store the data also on disk. But we just don't create files on disk, like open a file, write a file, close a file. That is not performant. Actually, are you familiar with memory mapped files, the concept? Okay, in databases, performance at this level is all about what type of system calls do you use or how do you synchronize the data on disk, but with the help from the kernel. When you use system calls like write and read, usually you have a lot of data copies between, in the operating system, you have user space and you have kernel space. So the data always go from user space to kernel and then back to user space, right? So the data gets copied. So they're not referenced because if you had just reference, you can crash the kernel, you got a lot of security implications. So you just copy the data. But memory mapped files is an optimization that is used by databases where you just create a file from a size and you just say, let's reflect this file in memory. So you don't do write, you don't do read. You just work with a memory buffer. And behind the scenes, sometimes you tell the kernel, hey, just synchronize the changes. So you forget about the concept of a file. It's everything in memory. Those are memory mapped files. So we did this concept. We implemented this. So we have this file system buffering mechanism, which is an hybrid solution where all the files, chunks that exist in memory are a reflection of a file in disk. And you might say, oh, but anyways, what is it? Because you can blow up the memory anyways. No, because now we have control. Because if we are saturating memory, we can say at some point, all these chunks that here are up and going to be retried, I don't know, in 10 minutes, there's no sense to have them up in memory. Why we don't put them down in a down state? Because we have a copy on disk. So we have this concept of chunks up and chunks down. So we can say, hey, this is a limit for memory. Don't use more than that. And if you are ingesting so much data and we have a lot of back pressure, hey, just write the data and put in a down state on disk. Yeah, we are using the disk as like a bigger buffer, right, under a failure condition. Those are part of the internals of how do we manage buffering. I think that this is one of the interesting concepts because people say, oh, what about memory? What about this? Do I need this? Yeah, you need disk. Nowadays, you cannot trust in memory because if something happens, you're going to either lose data or saturate the system, or the kernel is going to crash your program. So that was like a very, very quick overview of the engine. Do you have questions? Yeah, we have. Just enable file system buffering. If you just enable file system buffering, this is handled by you behind the scenes. Yeah, you don't need to choose between memory or file system. Just go with file system. 99% of users do that. Yeah, SSD will always times faster, and yeah, for production. The thing is that if you are deploying, okay, I'm sure that your applications are more resource intensive than the agent. So it's not usually something to worry about it unless you're writing, I don't know, terabytes, right? Yeah, we have some use cases with some customers that, hey, this is not working, or what they did is like, they test the agent by using a log generation tool. And the log generation tool was creating thousands of files on this, using system calls like crazy, and that tool was saturating the whole system that FluentBit could not work. Right? So we had to be very careful about what tools we use in general. But SSD, yeah, of course, that's the way to go. Yeah, you can install it locally in your computer, in a VM bare metal machine, or run it as part of a container.
Yeah, thank you. So is there a central FluentBit server that collects all the logs from different agents? I mean,
No, FluentBit is the agent.
FluentBit is the agent.
Yeah, it's the agent.
And so the central collection is done by, I know you probably went over it.
Oh, I get it. So, sorry, I misexplained that. Yeah. FluentBit can sit as an agent where the data is being generated, but also can work what we call an aggregator or collector. Also, you can make one FluentBit talk to another FluentBit over the network. So FluentBit can be used for edge processing, so you just set it on the edge, but also you can put it in the middle as a collector to receive the data from the other agents or from other source of data. Yep.
Okay, so we are actually at time. Since this is lunch break, you are welcome to stay here and ask Eduardo questions for as long as Eduardo can stay. But I want to let other people go who are grabbing lunch. And in the meantime, thank you so much, Eduardo, for a super informative